Okay, so hey everyone, today we'll be discussing the next problem, which is max multiple. So let's read the problem statement. So here you have been given a sequence of n non-negative integers, a1, a2 up till an, and we have defined s. Let s be the set of non-negative integers that can be the sum of k terms in a with distinct indices. And we need to find the greatest multiple of d in the set s. And if there is no multiple, we print a -1. So the problem states that say we have a1, a2, a3, and up till an, right? And say k equals 3. So this just means that set S will contain all three length subsequences sum in it. So set S will contain A1 plus A2 plus A3. It can contain A7 plus A8 plus A9. It can contain A1 plus A2 plus A7 and so on. All three length subsequences sum. And we need to find the maximum multiple of D in this set S, right? This is the set S. So let's try to dry run this for the sample input to understand the problem better. Okay, so here we have been given n equals 4, k equals 2, and d equals 2. And we have been given sequence 1, 2, 3, 4, right? So we'll list the sum of all two length subsequences, right? So I can consider 1 and 2. So I'll have a sum of 3. I can consider 1 and 3. I'll have a sum of 4. I can consider 1 and 4. I can have sum of 5. And similarly 2, 3, 2, 4, and 3, 4. And these are the all possible sums. And out of these, we have d equals 2, right? We need to find the max multiple of this in this set S. This is the set S. So the max multiple is 6, right? And that's the answer to our test case. So I hope the problem statement was clear. And okay. Now, first of all, you might have noticed that we all had n equals k equals d. The max value could be 100 only, right? So that just gives us a hint of, say, some sort of a DP solution, right? Picking and not picking the numbers. So say I A1, A2, A3, and so on up till n, right? I can try to pick A2 or not pick, and so on. And since n value is only till 100, so it definitely can be we can have a dynamic programming approach. Okay, so let's try to define the DP state. And before that, since we are dealing with sum here, right? So of course we can't store this in a DP state because sum, anyways, each element is still 1e9. And we have 100 elements, so the sum just goes 10 raised to power 11, and this we can't have this in our DP state, right? It will give us a TLE and MLE also. So when we are dealing with sum, it's better to store, say, sum modulo D, and this even helps in the transitions. And this is a quite common trick that when we are dealing with a DP problem and you are defining a state which is dealing with, say, some sort of a remainder or a sum or divisibility, then it's better to store sum modulo D instead of sum, because yeah. So let's define the DP state as, I define dp of I comma j comma k. It will store the max sum such that we pick j elements out of first I elements, right? And k is just the sum of these j elements modulo d. Okay, so reiterating on this. Okay, so right, yeah. So we had defined dp of I comma j comma k as, consider pick j elements out of the first I elements, and k basically stores the sum of these j elements modulo d, right? So taking forward this approach, okay, so yeah, so based on this analogy, what will be the base case? Simply dp of, say, 0 comma 0 comma 0 equals 0. This just means that we haven't considered any elements, we haven't picked any element, so we'll have sum of 0, right? So again 0 modulo d, which again will 0, and the sum is then 0, right? Now again, what will the final answer? We have been asked to consider all n elements. We need to pick first k element, any k element, sorry, and we need to have the sum a multiple of d, right? And maximum multiple of d. So when does that happen? When sum modulo d is 0. So that is, so we need dp of n comma k comma 0, and that will be our final answer. So let's first now dive into the transitions. Okay, so we have calculated dp of I comma j comma k. Okay, and it is not equal to -1. Equals to -1 just means that this state is not reachable. This can happen when say j is greater than I. That means say j is 3 and I is 2, right? So we are required to, out of 2 elements, we are required to pick 3 elements. That's not possible, right? So any unreachable state anyways is marked as -1. And that's what we have been asked in the question, right? If it's not possible, we need to print a -1. So now we need to consider for the AI plus 1, whether to pick it or not pick it, right? Say I not pick it. Now from here, what is the next state we'll go to? It will be, now we consider the first I plus 1, and j was a set of elements which we had picked. So we haven't picked anything, so j remains same. And since we haven't picked anything, our sum doesn't change, and so sum modulo d doesn't change. So this is it. And say we pick a of I plus 1, right? Say we pick a of I plus 1. First of all, what happens? Again, we go to the I plus 1 state. And initially we had j elements and we had picked a of I plus 1, right? So now we'll have j plus 1 elements. And now what will be the new remainder, right? So initially we had a remainder k and we added a of I plus 1 to our sum, right? And so k will just store this modulo d, right? So yeah, if we weren't picking anything, right, then we just go to the next state. The number of elements in the set doesn't change, and since sum doesn't change, so k doesn't change, which is sum modulo d. And say when we are picking a of I plus 1, so we add one element to our set j, and the sum just becomes, initially we had a remainder k and we added ai plus 1, so again we take a modulo d, right? I hope the approach was clear. Now let's look at the code so that we the approach gets even better, clearer, and then we'll discuss the time and space complexity. Okay, so here I have taken n and k, nkd as input, and I can take the sequence as an input and initialize the dp vector, a 3D dp. That's how we initialize a 3D dp, right? Of size n plus 1 comma k plus 1 comma d. And this is the base case which we had discussed. We loop through I, j, and k. And another trick just to how do we figure out the base cases, something something that doesn't include in a loop, we need to predefine it, right? So that's how we can figure out the base case also. And if this state is not reachable anyways, so we just continue. And if it is reachable, so we try not picking. So from I comma j comma k, we go to the state dp of I plus 1 comma j plus k. Wait a second. I'll just copy it here so that, okay. So yeah, when I try not picking it, right? So initially I was at dp of I comma j comma k, which I had computed, and now I am computing dp of I plus 1 comma j comma k. This is again maximum of just this and the previous state because we aren't picking anything, right? And say we try to pick. So the new remainder first of all will be what? Old remainder. Plus we have added a of I plus 1 to our sum, and we again take a modulo d, right? And that is, and the new state just becomes, now we are considering the first I plus 1 elements. And initially we had j elements and we picked a of I plus 1. So now we have j plus 1 elements. And this is a new remainder. and this value will be just maximum of again this value and the previous value, and a of I plus 1 gets added to our sum because dp of I comma j comma k just stores the sum, right? Max sum which is possible. And we do this only for j plus 1 less than equal to k because anyways we are not interested of sequences greater than length greater than k, right? That's why. And this is the final answer, which is dp of n comma k comma 0, which just means that we consider all n elements, and out of that we pick k lengths, all k length subsequences sum, and after that we need some modulo d0, right? The max multiple. So we have k value as 0. And coming to the time and space complexity, so first of all the space complexity is quite simple. It's just big O of n into k into d, right? The dp vector we are defining. And coming to the time complexity, again it's A of n into k into d because we are just running 3 loops, and the transition time is just negligible because we are just doing 2 operations. So thank you for watching, guys. I hope you understood the solution, and I'll link the code in the description. Thank you.